e to the 0 is 1. 1/2 times 1 is 1/2. 1/2 minus 1, negative 1/2. If I plug in bigger and bigger numbers, this is going to get smaller and smaller and smaller. So, for example, if I plug in 10, it's going to be 1/2 times 1 over e to the 10 minus 1, which is basically nothing, right? It's so small that I almost could ignore it. So it's going to be like negative 0.9999. So I can see my asymptote's going to be negative 1. Which makes sense because it's got a vertical shift down 1. Alright, so I've got 0, negative 1/2, and let me plug in some negative numbers, which will make this positive. So I'll plug in negative 1, I get 1/2 times e to the positive 1 minus 1. And this I'll just punch in my calculator. So e divided by 2 is 0.36. And then I'll repeat for negative 2. Let's see. .5 times e to the second, or e times e. Not sure what kind of calculator you'll have, but if you have like super basic calculator, you'll just have to know that e is like 2.7. And then even with a super basic calculator, you could type in 1/2 times 2.7 times 2.7 minus 1. I get 2.69, so I'll plot these negative 2 and then 2.69, negative 1. See, I should be starting at the origin. Negative 1.36. I get my asymptote. Domain, all reals, exists everywhere. The range is y is greater than negative 1. The y-intercept, 0, negative 1/2. Asymptote y equals negative 1/2, negative 1. It's increasing nowhere because it's always going down. As x goes to the left, y is going up. As it goes to the right side, y is going to negative 1. Ooh, yuck. Alright, yeah, we can do this as a transformation, but we'll just stick with making tables. And I'll probably always start with 0. Seems to always be a good number to plug in. Alright, so again, negative 2 times 2 to the 0, which just makes that 1. So I got negative 2 plus 3, I got 1. I'll try, I guess I could plug in 1, but that's going to be some decimal. It's fine if you got a calculator, but I'm going to plug in 3 since I can see that's going to work out nice. So 3 times 1/3 is 1. And I get negative 2 times 2 to the 1 plus 3. So I get negative 4 plus 3, negative 1. I guess I'll go the other direction. Negative 1's not good, so I guess I'll go negative 3. See what happens. Negative 2 times 2 to the negative 1 plus 3. So that's 1/2. 2 to the negative 1 is 1/2. And that's just negative 1. So plus 3 is 2. All right. I should have some kind of asymptote here. I don't know where it's going to be. Let's see if I plug in a really big negative number. So I go negative 9. Negative 9 times 1/3 is negative 3. so there I get 1 over 8. And that's negative 1/4. And it's 2 3/4. So I can see, yeah, this looks like it's suspiciously getting closer to 3, which is, yeah, I probably should have known it's getting close to 3. So and it's an upward shift, a vertical shift of 3. So yeah, pretty sure that's my asymptote. All right, let me start plugging in some points. 0, 1, 3, -1, -3, 2. I did -9. It was really close to 3. So it's looking like it's a function. As x goes to the left, looks like y is going to 3. As x goes to the right, y is going to -infinity. All right, some more horrible stuff here. I'm just going to continue with the same approach. Plug in 0. This isn't great. This one's definitely, it's a horizontal shift to the left, 1. And it's also a horizontal shrink by 1/2. I'm still just going to go with these numbers. All right, 3/4. 2 times 1 is 2. Okay, I get -5. That's kind of sucky, but 9 over 16 minus 5. So it's pretty tricky, but -4 and 7/16. Yuck. So maybe 0 wasn't such a great number. I mean, it's usable. But this time I'll try and pick something better. I guess I'll plug in -1. That looks like a good one. -1 turns that into 0. 2 times 0 is 0. 3 to the 0 is 1. 1 minus 5 is -4. All right, plug in -2, I guess. -2 plus 1 is -1. 2 times -1. It's -2. So this flips and becomes 4/3 to the second. Which becomes 16/9. -5. Terrible. Alright, which becomes, this is 1 7/9. Kind of hard. You can do that in your calculator, I guess. But take away the 1, it becomes 4. So -3 2/9. Yuck. Oh man, what number was I? -2. All right. I can see my asymptote is going to be -5. 1, 2, 3, 4, 5. See, I get 0, -16, 7/16. Sorry, getting close to my asymptote. -1, -4, -2, 3 2/9. All right, I'm just going to call that enough. 3 points. Okay, demand reals. As x goes to the left, y is going to infinity. As x goes to the right, y is going to the asymptote. To condense, you first have to move these exponents up. and then addition becomes multiplication. Another condense, so I gotta move this 1/3 up. And that, I guess I'll just simplify that. So 64 to the 1/3 is 4. And then everything that's negative is a denominator. So that 16 is going to go on the bottom while it's going to simplify. So it's ln of 1/4. I guess that's it. Expand. So I've got 3 terms. These 2 are going to be positive, and this one's going to be negative. So it's a, let's b to the 1/2. B to the 1/2 minus log base 5 c to the 4th. And then these exponents need to come down. And that's it. Number 7, these are both base 5 numbers, so I gotta go 5 to the -1, so u squared plus 8. 5 to the 3rd, u squared minus 3. Then multiply the exponents. So -u squared minus 8, multiply 3u squared minus 9. And then I'll solve that. So 4u squared equals 1. Divided by 4, then square root. Don't forget the plus or minus. Okay, these are both base 2 numbers. That one's 2 to the 5th. And then just finish the same way. So this one, I'll add these 2 exponents. And then the bases can go away. So these logs cross out. This you'll condense, and then the logs will cross out. Gotta move that exponent up. Then once you have a single log on each side, only then can you cancel logs. You can't do it up here. Only when it's a single log on both sides. No coefficients, no adding one. So I guess with this one we'll still condense. So it'll be 2x squared over x plus 3. And then time to get rid of the log. So the base of the log becomes the base of the exponential on the other side. So that's 8. 2 to the 3rd is 8. And for this, you always multiply by whatever denominator you have. So x plus 3. And we get 2x squared minus 8x minus 24. I'll have to factor that. Maybe I made a mistake. It doesn't look like it factors. Yeah, what am I doing? That should be 12. I probably made some other factors. For these, you're supposed to plug it back in and make sure it works, but since it doesn't make either of these negative, I guess I'm okay. Yeah. Add 9, 5. And then the base of the exponential will become the base of the log on the other side. And this you just plug in your calculator, divide by 2. So here we want to multiply by the reciprocal first. 49. And then the base of the exponential will become the base of the log on the other side, which is ln 49, which you just type in your calculator. Add 5 and then divide by 6. Calculator. What's your bank? And so it's this one. Just move the n up. This one. Anytime it's a 1, it's just 0. If the base matches the argument, it's 1. For example, log base 2 of 2 is just 1. This one, you do the flying exponent. You get n log base b of b, but this is 1, so just n. This is the same thing. These cancel the n. I say same thing. It's like f and g are pretty much the same thing. This is a log of an exponential. This is an exponential of a log. They cancel. I guess b of a. This, I guess you can use change of base formula. So it's going to be that one. Expand the log. I guess you can move that 3 down there. I'm not sure what they really want. And there's 2 plus log base 4 of x. So this one, this flying exponent doesn't come down because it only applies to the 2. But then you do bring it down. Condense the log. I'm gonna skip that one, I guess. It's log 64. Everything that's positive goes in the numerator. Everything that's negative goes in the denominator. So let's see, 2 to the 3rd. I should have moved this up first. And I could have taken it up like that. And then it would have gone in the denominator, in the numerator. But then since it's a negative exponent, it actually ends up in the denominator. This one, 3x, 25. And the base of the exponential becomes the base of the log on the other side. Base of the exponential becomes the base of the log on the other side. This you punch in your calculator. How many 2's does it take to make 16? It's 4. Add 2. We have a ln we want to get rid of. The base of the ln is e. So the base of the ln will become the base of the exponential on the other side. And subtract 4. That's it. This one we'll multiply by, and then we'll subtract 4. And then we'll multiply by 3. And then the base of the log, which if it's not written there, it's 10. The base of the log will become the base of the exponential on the other side. So that's 1,000, and then add 1. So the base of the log becomes the base of the exponential on the other side. Now you can plug in your calculator. The base of the log becomes the base of the exponential on the other side. That's 1 over 100, or 0.01. I already did some of those, right? Describe the transformation. So the parent function for this one would be y equals 4/3 x. Let's see, and it's got a reflection across the x-axis, which is a vertical flip. These two are horizontal because they're close to the x. The one that's multiplied is a stretch. Seems like it'd be a horizontal stretch of 2. But it's the opposite. It's horizontal shrink by 1/2. And that one looks like it moves to the left 3, but it's right 3. And up 1. Let's see, this one, parent function is 7 to the x. And let's see, it's got a negative, so it's got a reflection across the y-axis, which is like a horizontal flip. This number 3/2 is bigger than 1, so it's what seemed to be a stretch. It's actually a horizontal shrink by a factor of 3/2. And then it's shifted, vertical shift up 3. If the base is bigger than 1, it's growth. If the base is smaller than 1, then it is decay. Growth. Pretty stinky. Zero. I can't plug in 0. Plug in. If you plug in 1, it turns that into 0, so we get 0. If you do 1/4, that's a good one because log base 1/4 of 1/4 is 1, so you get 2. And then if I plug in 4, you probably have to use your calculator for that. You might not have a calculator. But since 4 is 1/4 to the -1, that means this will be -1, so we'll get -2. Log normally looks like that. Since there's no horizontal shift, I know my asymptote is still there at the same place. All right, 1/4, 2, 1, 0, 4, -2. So that's enough for me to, so it's like that. Domain. X-intercept 1, 0, asymptote. This one, it doesn't go to -infinity to the left because it only goes to 0 towards the left. Yeah, this one, you'd need a calculator, but center point's going to be -5, because that's what's going to turn, oh no. When this is, whatever makes this 1 will be your center point, which is -4. And normally log goes through 1, 0, so I'm calling that our center point. But it's been shifted to the left 5, so it was there 1, 2, 3, 4, 5. And I guess that helps me with my asymptote. Yeah, if I can realize that's a horizontal shift left 5, that helps a lot. All right, so if I plug that in, I get 1 is 0. And there's no easy numbers to plug in for this that are going to make integers. The only one that is nice is -4. So for those, you would have to use a calculator. So I'll plug in like, I don't know, -3. So then I get ln of 2, it's negative, I don't know what that is, but it should end up looking like this. It says negative. All right, I'll stop there.